All right, I know we've gone over compound interest. We're going to go over it again. I feel like hopefully this explains a little bit of when you're supposed to use a certain equation, because there's 4 different equations if you can see what we're doing. I know there's a lot of extra stuff, but these are the equations. We have our growth and decay formula, okay? We have our simple interest formula. We have a formula for compound interest. Okay, and then we have compounded continuously. Okay, so what I want to show you guys is how these are kind of intertwined, especially these 3, and hopefully you have a better understanding of when to use it. Okay, so if we look at our growth and decay formula, we have y equals a times b raised to the power of x. Okay, a is going to be our initial value. All right, so it's our initial value, our starting value. So in a problem, and the word problem is going to say, hey, we started with this amount. Okay, so that's where you would put for your a value. Okay, your growth or decay factor is going to be the b value. Okay, now some of us are struggling being able to identify which one is the initial value versus the growth or decay factor. Okay, so the growth or decay factor always has your exponent. Okay, so that's how you identify the growth or decay factor. It always has your exponent of x. Okay, so when this growth, if it's a growth, that means the b value is greater than 1. So you'll have like 2 or 3 or 4 or 5 or anything greater than 1. If this is a decay, then your b value is going to be between 0 and 1. So it could be like half. Okay, it could be 0.75. It could be 1/3. Those are all examples of decay. Okay, so when do I use this formula is when in my problem it tells me like these keywords. It has like double, triple, quadruple, etc. You might have a half-life formula, or it might say you got cut in half each day. So if you see terms like this, that's when we use this. Okay, so things that are tricky, let's say we had just this right here. Okay, y equals 3 to the power of x. 3 here, since it has the exponent of x, is our growth factor. Okay, our initial value here, okay, is not written, but it would be a 1. So 1 times 3 to the power of x. So 3 is actually our growth factor. Okay, so hopefully that clears up some things for you guys. All right, so moving on to simple interest formula. A still stands for initial value. Okay, it's our starting value, so that's the same thing as the growth formula. Okay, then we have parentheses, and inside the parentheses we have 1 plus or minus r. R is new in this formula. R stands for the growth or decay rate. Okay, growth or decay rate. So that means R, in our problem, it's going to give you a percentage. It's going to say, hey, it is growing by 4%, or it's decreasing by 5%. Okay, so it's going to give you a percentage. That's what we put in for R. Okay, before we plug it in for R, we have to remember to convert to a decimal. Okay, so for instance, if it said something was growing at 6%, then 6% converted to a decimal is 0.06. So we would actually plug in 0.06 in for R. Okay, and so we only use a plus if we know it's a growth. So it says it's increasing in value, so it would be 1 plus 0.06. Or if we knew it was decreasing, if the problem said it was decreasing by 6%, then we would use 1 minus 0.06. Okay. And then t is sort of new. T is just going to represent time. Okay, so whatever, however long it gives you, that's what you plug in for t. All right, so we use this simple interest when it just gives us a percentage. So it'll just give you a percent, whether it's increasing or decreasing by a certain percent. Okay, and then that brings us to our last 2, compound interest formula. Okay. So our compound interest formula looks somewhat different, okay, but these letters still represent the same thing. So this time we have y equals p, so capital P. Capital P is just like our a value. It was our initial value, okay, so wherever we start with in that problem. Okay, so it'll say, hey, we started with $1,000 in our bank account. So this is usually going to represent money. Okay, and then we have 1 plus R, still stands for the rate, the percentage, divided by N. Okay, and then raised to the power of NT. So N is the new variable here. N represents the number of times something is compounded. So you're going to put the same number in for both the denominator here and the numerator there. Okay, so number of times it's compounded. What am I looking for in the problem? How do I know that this is the formula I'm going to use? So in that word problem, it'll say something about, yeah, you have an investment. Okay, let's say I have a $100 investment and the bank account gives me, 3%, and then it says compounded, and it'll say one of these terms right here, or something similar to this. It'll say, hey, it's compounded yearly. If it's compounded yearly, then that's just one time within that year. Okay, if they say it's compounded semi-annually, well, that means that it's compounded 2 times within that year. Quarterly would be 4 times in that year, monthly 12 times in that year, daily 365 times in that year. So these are just common ways that it's compounded. So if you see any of these key words, then you know that compound interest is the formula you use. Okay, and then the last thing, this equation, which is fairly new, y equals p, so p is just the initial value, times e raised to the power of rt. R is still the rate, t is still time. Okay, so e, okay, e is kind of like pi. It just has a value. Okay, so pi has a value, if we just estimate it, 3.14, right? Well, e is just a number. Okay, it does have an estimate of, just like pi, this is about 2.17. Okay, there is a button for e. So when we have something that says compounded continuously, so continuously is the key word. If you see continuously compounded, this is the formula you're going to use. Okay, and so when we plug this into our calculator, if we hit the second button, and then it'll activate all the blue buttons, and you'll see a button or something in text that has e raised to the power of, and then it'll have a blank. Okay, and this is just on the left-hand column of your calculator. So you would hit second to activate the blue text. This would be in the blue text, and then we could just plug in the information and hit enter and get our calculation. So hopefully this video helps you understand of when to use what formula. I know it can be confusing, but hopefully you're kind of getting the idea now after practicing this for a couple weeks. And if you still have questions, then please contact your teacher of record, and we'll do our best to help you out. Thank you very much.